Hello and welcome all. So we are presenting our final presentation for our research project, and I'm doing this presentation with Vidit, Zeng and Owen. My name is Rishi, and our test goes about the IMDB movie reviews analysis, and our research question goes with if online movie reviews and ratings can predict the consumer sentiment behind a movie. So going forward next. So the data sets that we are using, the first one is the movie profile, which describes about a movie and all its features, starting from the title, its rating count, title name, the class, length of movie, genre and the release date. All of these features have been important throughout our research analysis. And our second data set would be the movie reviews. These are the movie reviews which are given by the users based on their open-ended text as well as the rating that they give towards each comment that they are giving out. This dataset consists of the title ID, title, username, user URL of the user, the date, the timestamp of the movie review, helpfulness and the open-ended text. Moving forward, the research questions which we are going through our research topic. The first one is if the movie review sentiment is predictive of the features, and the second one is if the movie review sentiment predictive of the numeric rating which is given by the users towards the review comments. And the third one is if the analysis of the movie review sentiment suggests a better scale to which to rate the movies or the other products. Research question 2 goes how helpful a review comment could be. What is the most important factor that makes a review helpful? And the last research question is what is the impact of factors like movie genre, star cast, movie budget, etc. on the overall movie rating. So these are the brief about the research questions. Moving forward.
So in the first two milestones, we did some preliminary text analysis, and this was using the package SUSE. So here we just, you can see the overall word cloud, and you can just see some prominent words like movie, film, Oscar, and also what we found was that out of the total 390,284 reviews, about 100,000 were negative, whereas 290,000 were positive. And also for the features for our first research question, what we had was different emotions. So we had like anger, anticipation, disgust, fear, joy, trust, and these emotions were used as predictive features. The command that we used was get NRC sentiment, and these features have been used further in our analysis. So now coming to the new analysis, firstly we did a comparative approach in the population and a sampled data set because our analyses were computationally very expensive. So for SVMs and neural networks, we just made a sampled approach, and what we see is that it's fairly representative of the population. We took a 10% sampled data set, and we see that the review class variable is a bit unbalanced, and also the action, comedy and romance genres, the reviews for these three genre movies were overrepresented. Next. So coming to the support vector machines, for RQ1A, what we want to do is like what features are predictive of the movie review sentiment. So we use the class E1071, and our dependent variable was a continuous measure. It's the value of the sentiment score. So we ran a support vector regression, and what we see is the mean, the MSE, the error is 11.56, which is pretty low. So I think SVR does a good job here. Next. For 1B, we wanted to look at like what's the impact of sentiment score on the rating score, which is the number of votes which are left by the user at the review level. And here again we used the same package E1071, and we find a very low value of MSE at 6.6. So again, a support vector regression does pretty well in predicting the rating score. Next. For 1C, we wanted to look at like whether we have a better scale of representing reviews. So here we went with two approaches. The first was wherein we had a review class variable. We made it a binary variable in terms of ratings, more than 5, then it was a 1, a high level, or it was a 0. So here what we do is using the repeated CV training control method in the carrot package, using a linear kernel, what we find is that the accuracy is just over 70%, and also what we see is that the sensitivity is 0 and specificity is 1 for the low class of reviews. So again what we see is that because of the undersampling, it's possible that the true negative rate is very high for the lower class of reviews. Now On the other hand, when we use a radial kernel, we see that the classifier accuracy is slightly better, it's 72%, and we also see that these results are marginally better than the linear results. And we also see here that the low sensitivity value for the low rating reviews, it could be because of an unbalanced random sample. Next, we also looked at the multi-class classification approach. So here what we do is we have 3 classes of the reviews. So these are the low, medium, and the high. Again, we have 3 bins basically. So it's based on the number of votes that reviews are getting. And again, we do a linear kernel as well as a radial kernel for the multi-class classification. And what we see is the classifier accuracy is just 50% for the linear case. Next. Whereas for the radial case, what we see is that the accuracy is 53%. But what we see is that it's doing a pretty good job in predicting the true values for true positives for all the 3 categories. Like it's 0.17, 0.27, and 0.83 are the true positive rates. So I believe this multi-class approach does better than the binary class approach for both the linear and radial kernels. Next. For research question 2, we visualize it in 2 ways. The first, we look at the number of helpful votes a review receives. So that's our continuous measure. And again, we run a regression, a support vector regression, but the MSE value is very high, so this is not a good methodology for RQ2. And next we look at the binary classification. So here we visualize a review as being helpful or not. So we have a review helpful flag as our dependent variable. And again, for the linear kernel in the repeated CV cross-validation method, what we see is that the accuracy rate is about 80%. But once again, for the helpful category, the classifier has a sensitivity of 1, which implies that it correctly predicts all the helpful reviews. Next. For the radial case, what we see is that the accuracy is slightly better. But once again, what we see is that the sensitivity value is very low for the unhelpful reviews. And this is again due to an unequal mix of the helpful and unhelpful reviews in our sampled data set. Now for the third research question, we wanted to look at the overall movie rating based on some movie level features like the movie age and the popularity of the movie and the overall sentiment of the movie. So here what we see is that we ran a support vector regression and the MSE value is very low, it's just 0.347. So a support vector regression does a pretty good job in predicting the overall movie rating. Now for the neural networks, I'll ask Owen to take over.
Thank you, Vijay, for that extensive overview of SVMs. I will not be going as in-depth into our code for neural nets because, as Vijay just demonstrated, we had used the same dependent and independent variables for these analyses. And I will be covering how my models benchmarked against his. However, first I wanted to touch briefly on our implementation of train control for Caret. We picked 3 methods by which to examine the performance of our models: repeated cross-validation, and optimism boot. These were selected primarily based on resource constraints. SVMs and neural networks, as we've mentioned, are both extremely resource intensive. We tried a few other methods. They were taking hours and hours and hours to complete, so we settled on these 3. Broadly speaking, the results from each train control method tended to agree. You can see the strong relationship between the results from the model run with cross-validation and optimism boot, as well as, if you hit the next slide, a slightly less strong relationship between optimism boot and repeated cross-validation. When we compare these with our final model, and there's one more, but if we compare these with our final model, hit one more forward, cool. We still get a large degree of inaccuracy despite the fact that all 3 train controls were outputting consistent results. So having consistency in your train control does not necessarily increase your chance of getting it right. That said, depending on our train control implementation, we did sometimes get extremely varying results. So here again, talking about 1B, we see that for optimism boot and plain cross-validation, we saw that same linear relationship between the 2 predictions. However, if we look at the next slide, Here we see something different. Optimism boot and repeated cross-validation disagreed significantly. Repeated cross-validations tended to skew higher, while optimism boot tended to skew lower, which gives you this clustering up towards the top left side. Comparing it with just repeated comparing it with optimism boot, next. Oh, one back. I jumped one ahead. But this is, here you can see that repeated cross-validation that's skewing high compared to the sentiment score, which is our dependent variable for this question. And if you hit the next slide, this was with regular cross-validation compared against the same test set. So our method of train control actually significantly impacted the predictions that we were getting. Finally, I just wanted to cover a few more questions. This was a quick plot of how we did for predicting helpfulness, whether or not a movie is good, based on sentiment. This was largely accurate, as Vita pointed out. Neural nets performed slightly worse than SVM, which we'll talk about at the end, if you hit next. I did want to flag that for question number 2 in particular, we did an interesting thing. With the initial 77% accuracy, we included 2 of the factors that we used to decide whether or not it was helpful, which was our dependent variable. Theoretically, I would expect the algorithm to be able to figure out that there's a relationship here and predict it with high accuracy. While it did get slightly higher accuracy, it still didn't boost up to 90%. So there are flaws in these models.
First thing, we cannot get a direct answer for our research question, but still it plays a very important role to get insight into those different data sets. For research question 2, we have the review level data, and for research question 3, we have the movie level data. So we do the clustering method on these 2 data sets. The method we choose is partial clustering, hierarchical clustering, density-based clustering, spectral clustering, and a mixture model. For the data normalization, we choose max-min normalization. And let me just highlight some interesting results. And this research question 2, for the k-means, we get this kind of results, which is not very significant to get a clustering when we cite the cluster of 7, which we aim to correlate it to 11 different ratings for each view. Yes. And also we tried different key methods, PAM function, and we still get a very similar and clear clustering results. But for research question 3, we get better results. For k-means, we have separate clustering features under this principle that component plotting for first component and second component, and which indicate that there are some latent clustering features behind this research question 3. Also, the PAM function can get a very similar results, but you can see this 2 cluster overlays, so it's not as good as a good result as the k-means. For the hierarchical clustering, this is a danger ground for research question 2. We cannot dig into the results, but get a very overview of that. For research question 2, there's no significant clustering compared to the research question 3, since you can see some very strong branch at the very beginning of the head. So for the movie level data, maybe there are some strong clustering behind them. And for density-based clustering, it outperforms other results in drawing this plot. You can see the separate clustering features, and maybe just for the research question 2, we get maybe 2-bit clustering. For the research question 3, we get 4 clusters, and those 4 clusters are very separated. It's a very good result. So if you want to know the features under that, that will tell us how it is clustered. For the spatial clustering, due to the restriction of our computing, we cannot get the results for research question 2 because data is too many. But for the movie level data, the 5 features we applied is there's a plot to show the relationship pairwisely. So each plot will tell you how the different clusters distribute in the similarity or the distance between these 2 features. So for this one, the green and the black cluster just separate at this line. You can see there's a little line here. So that's tell you how the pairwise variables will affect the clustering result. For the model-based clustering, or aka the Gaussian mixture model, we can get a similar results. For research question 3, there's 2 clusters, and the interpretation is similar to the spectral clustering. And we get 2 clusters for research question 2, but for research question 3. But for research question 2, we cannot get a very good result for this plot because too many variables. So a brief conclusion is for k-means it's a very reliable algorithm, but for hierarchical we can get a consecutive view. Steady scan is the best if you want the most discriminated results. And spatial clustering and mixture model clustering can output very complicated and rich information, but it's free of parameters counting, but they are very complicated math behind them.
To talk about the comparative analysis of our models using Caret. For the regression methodologies across milestone 2 and 3, we looked at line regression, multivariate regression, support vector machine regression, and neural network regression. You'll notice neural network has a significantly different value than in the others. This was due to some of the normalization that was applied in order to get the values down significantly to make them usable for neural networks. However, there is a similar relationship that you can see in the numbers for neural networks and in the numbers for other methods, where we saw a decrease in our mean square error going from here to here, but for Q2 and Q3, we saw a slight boost. Okay, next. For repeated TV, binary classification, this is a lot of information that I'm not going to cover in the remaining 30 seconds. That said, we did attempt to run both linear and radial kernels for both SVMs and neural networks. Neural networks, the code crapped the bed. I don't know what happened. R exploded every time I tried to implement the model. However, for radial, VDIT observed that radial had significantly higher returns, significantly better results than the linear functions. And for neural networks on linear, my accuracy roughly fell behind SVMs just by a hair. Some of that is likely due to the fact that VDIT is a better coder than I am. Some of it is also likely due to the fact that Caret's neural net model is not a particularly robust neural net model and could be improved. And hit next. Similar results here. You again see SVMs. Radial continues to outperform linear, with neural nets falling somewhat behind both SVM methods. Same thing for optimism boot. Linear, radial for SVM classification ahead of linear, ahead of neural networks in terms of accuracy, sensitivity, and other factors. And that's all. Thank you so much for watching our presentation. Hope to see you around again sometime soon.
Yeah.